Dear all, let us see today the heading integration of irrational functions. We have many types of problem. Let us see one by one. Evaluate integral dx by. It is like a plus b, right? Whenever you have this form, find a minus b, multiply and divide by a minus b. So root of x plus 1 minus root x by root of x plus 1 minus root x. So denominator which is a minus b into a plus b form. A square minus b square. And hence simplifying this a square minus b square, you will get 1. And we have to integrate it, right? Let us separate the integrals. And we know formula integral x bar n dx, which is x bar n plus 1 by n plus 1. And we know ax plus b whole bar n dx formula. Ax plus b whole bar n dx, which is ax plus b whole bar n plus 1 by n plus 1 into a. Hence this 3 by 2 can be taken to numerator, which becomes 2 by 3 x plus 1 whole power 3 by 2 minus 2 by 3 x power 3 by 2 plus c. So which is first type. Let us see similar problem of the same type. Integral x into root of 1 minus x by 1 plus x. So denominator is a plus b. What we do is denominator is a plus b. Multiply and divide by a minus b. Okay. Multiply and divide by a minus b. Root of 1 plus x. Multiply and divide by root of 1 minus x. So when the denominator is a plus b, find a minus b, multiply and divide. Hence root of 1 minus x into root of 1 minus x is, we know 1 minus x. Root x into root x is x, right? And this is root of 1 plus x into root of 1 minus x. Root a into root b, right? Which is root of ab. Root a into root b is root of ab. 1 plus x into 1 minus x, which is a plus b into a minus b. A square minus b square. Okay. So when you see a square minus b square, it is root of 1 minus x square. In order to integrate, let us separate the integral. So since the expression is in the form root of a square minus x square, you can use trigonometric substitution. Even this can be done by ordinary substitution. Put 1 minus x square equal to t. 2x dx is dt. So you can use ordinary substitution. But here you cannot. You cannot use ordinary substitution because it is 1 minus x square, numerator is x dx. It is 1 minus x square, but numerator is x square dx. So ordinary substitution cannot help. So we have to go for trigonometric substitution. You please go through the topic trigonometric substitution. So when the expression is root of a square minus x square, put x equal to a sin theta. Our a is 1 here. So instead of using here ordinary substitution, here trigonometric substitution, let us use in common trigonometric substitution. Because denominators are in the form c a square minus x square. Root of a square minus x square. So put x equal to a sin theta. So the dx becomes cos theta d theta. Let us write here in place of x and in place of dx. See, simplify. Root of 1 minus sin square theta is cos square theta. When you take square root of cos square theta, it is cos theta. Cos theta get cancelled, which is sin theta d theta. Minus, when you simplify the term, you will get sin square theta, right? It is cos theta get cancelled. It is cos square theta, right? Cos square theta. Numerator is x square. That's why sin square theta. So when this can be integrated directly, here you have to use formula. Sin square theta equal to 1 minus cos 2 theta by 2. And hence integrate each term, right? Integrate each term. And write sin 2 theta. Listen here, you cannot leave here the answer. You cannot leave here the answer because the integration is given in x. The integration is given in x. So our answer must be in x. Okay, our answer must be in x. So in order to get answer in x, let us use this trigonometric substitution. X equal to sin theta. We use this trigonometric substitution and hence we find the answer of cos theta, theta when x is sin theta, theta is sin inverse of x. theta is sine inverse of x. Similarly, when x is sine theta, find cos theta. And here write sine 2 theta as 2 sine theta cos theta because you cannot find the answer of sine 2 theta. Find sine theta answer, cos theta answer with the help of this sine theta is x. Find cos theta answer from sine theta. In order to get what is cos theta in terms of x, let us use this Pythagoras theorem. See, sine theta is x, which can be written as x by 1. We know sine theta is opposite side by hypotenuse. So it is, listen here, the opposite to right angle is hypotenuse. The opposite to theta is opposite side. Hence opposite side is x and the hypotenuse is 1. Find adjacent side. By Pythagoras theorem, adjacent side is square root of hypotenuse square minus opposite square. Adjacent square is square root of hypotenuse square minus this opposite square. So cos theta is adjacent side by hypotenuse. Root of 1 minus x square by 1. That is simply root of 1 minus x square. So you know what is cos theta in terms of x, what is sine theta in terms of x, what is theta in terms of x. You can substitute it here. Okay. Cos theta in terms of x, theta in terms of x, and sine theta cos theta in terms of x. Since the integration is given in x, you must write answer in terms of x, not in terms of theta. That's why, okay. Plus c, we add constant of integration being indefinite integral. So you go through indefinite integral heading and try to understand. Let us see type 2 problem. How can we identify type 2 problem of irrational function? You look at this example. Whenever we have function with power 3 by 2, 1 by 2, root x is x power 1 by 2, or ax plus b whole to the power something, then we say it is type 2. How do we do this problem? First, let us consider the given integral as I, x to the power 3 by 2 minus x to the power 1 by 2. So we have to assume, listen here, first you take LCM for the denominators. Here it is 2, here it is 2. Hence LCM of 2 and 2 is 2. So put x equal to the substitution now. The substitution, since LCM is 2, we have to substitute x equal to u square or t square. Okay. So when LCM is 2, here you choose the substitution u square. So find dx, and hence see, after finding x and dx, assuming x and finding dx, substitute it here. Since x is u square power 3 by 2 is u cube. Then u square whole power 1 by 2 is u. And next it is c, taking u common, u numerator u and denominator u get cancelled. So it becomes 2 into integral du by u square minus 1. How can we find? There is a direct formula, right? There is a direct formula saying integral dx by x square minus a square. There is a direct formula. Integral dx by x square minus a square. Okay. 1 by 2a into log of x minus a by x plus a. So here you will do 1 by 2 into log of u minus 1 by u plus 1. Where u is x square, x is u square, hence u is root x. Okay. U is root x. So we should get answer in terms of x, which complete problem. And similar problem we have, which is with ax plus b whole power 1 by 2. When it is x to the power or ax plus b whole to the power, we choose this type. So here what we do is, let us assume there is no, here we can simply say LCM is 2. Okay, it's being only one term, only 1x plus 1 whole power 1 by 2, we can say LCM is 2. So I'll choose substitution, x plus 1 equal to u square. So x equal to u square minus 1. Hence see what is dx. Hence change this function, entire function to u. And then after finding u, listen here, you can use here trigonometric substitution. You can do trigonometric, I'm sorry. Here it is not with the square root, right? If the denominator is with square root u square minus 1, you can go for trigonometric substitution. But here we cannot go trigonometric substitution. So we have many methods, and I have done a method for you here. Add and subtract 1. Add and subtract 1. Hence you see, separate the term u square minus 1, 1 by. U square minus 1 by and 1 by. and these two get cancelled, integral du. And there is a formula just now we had seen, right? Integral dx by x square minus a square, which is 1 by 2a log of what's the term, x minus 1 by x plus 1. Okay, x minus a by x plus a, where a is 1 here. Finally replace x plus 1 is u square, hence u is root of x plus 1. U is root of x plus 1, right? U is root of x plus 1. Hence you do which complete this problem. Okay, so you can do similar such problems. Okay, you try. So let us see another problem of the model. The same model. Okay, root x, cube root of x. You take LCM and you do. You try. Okay, take LCM and you do. Next we shall see type 3. It is integral some linear factor into square root of linear factor, or quadratic factor into square root of linear factor. Whatever it is, do this method. Okay, so integral, it is difficult to keep in mind all these. Okay, difficult. We have many types of irrational function problems. So you try to keep in your mind the method. Okay, so it is, see, we have to use substitution. Put x plus 9 equal to u square. Hence change entire function to u, and automatically you can integrate. Okay, you can integrate. That is a formula. Integral du by dx by x square minus a square. Right, 1 by 2a log of x minus a by x plus a. Finally replace u. X plus 9 is u square. Hence u is root of x plus 9, which complete the problem. This is type 3. Okay. Next comes type 4. Here you can see it is integral dx by px plus q into root of, it's linear factor into root of quadratic factor, square root of quadratic factor. Okay, so here the substitution is put px plus q equal to 1 by t. Okay, so what we do, first you consider I is equal to the given integral. Px plus q is x plus 1 here, which is equal to 1 by t. Hence find dx. So listen here, x plus 1 dx, you know, when you integrate 1 by t, it is minus 1 by t square. Then when you differentiate 1 by t, it is minus 1 by t square. Then you differentiate t, it is dt. Okay, so since we have here, listen here, I am going to change the entire function x to t. So I will write x plus 1 as 1 by t and dx as minus 1 by t square dt. Then how can I write this in terms of t? I have to find what is x in terms of t. Then I should find what is x square in terms of t, 2x in terms of t, and finally what is this entire expression in terms of t. Okay, so in order to get this entire expression in terms of t, I first find what is x in terms of t. X equal to 1 by t minus 1. So let us take this expression, substitute wherever x, the term, right, multiply and simplify, and you will meet this answer. When you simplify, you will meet this answer. Okay, and after that, see, take LCM. This is my answer. I substitute this, the value of this expression, then dx, x plus 1, etc. in the given integral. Okay, in the given integral. Let us see. Here I have substitute. First I have listen here. I still simplify. Take since I want t square to be independent with the coefficient, so I take minus 2 outside. Then I try to write this as a perfect square term. Okay, here I have got difference of two perfect square terms. Root 2 the whole square. It is 1 by root 2 the whole square. Difference of two perfect square terms. Why do we write this as difference of two perfect square terms? So that we can integrate. We can use formula. Integral dx by root of a square minus x square. Okay, that's why we do all these steps. Take minus 2 outside. Then listen here, it is a square term, 2ab term. Find b square term, add and subtract b square term. Okay, and hence listen here, these three can be written as a minus b whole square. Simplify these two. And let us, since I have negative sign, let us multiply negative sign. And this is difference of two perfect square terms. So I have substituted all the values here, right? All the values in the given integral, and I have simplified. I have taken root of 2 by t outside. Root t square is t. And the rest of the term as it is inside square root. Okay. Take constant term outside. Now again use substitution. Put t minus 1 equal to u. Okay. So that you can use integral root of a square minus u square formula. A square minus u square formula. Integral dx by root of a square minus u square is sine inverse of x by a. Our x is u and a is 1 by root 2. So root 2 goes numerator. Let us write u in terms of t first. What is u in terms of t? U is equal to t minus 1. U is equal to. Let us write u in terms of t. Later we write t in terms of x. Okay. Which complete problem. Since the given problem is in x, our answer must be in x. Okay. Which is our type 4. You try this problem. You try this problem the same method with the linear factor into square root of quadratic. Okay, factor. So you try this problem. I have given you the answer. Okay. So it is next type 5. Evaluate integral dx by a quadratic polynomial into square root of quadratic polynomial. So how do we do then? If it is a quadratic polynomial to square root of quadratic polynomial, you can write it as a perfect square term. A minus b whole square form. You can write it as a perfect square term. See, x square minus 6x plus 9, which is x minus 3 whole square. Similarly, this quadratic polynomial can be taken. It can be written as a difference of two perfect square terms. It can be written as root 5 the whole square. Difference of two perfect square terms. Okay. So let us write those terms here. Now we will use substitution. The same method which we had seen. Put x minus 3 equal to 1 by t. So dx becomes minus 1 by t square dt. And hence wherever x minus 3, listen here there is no x to find like last problem. Right. You substitute for x minus 3 1 by t. 1 by t. Okay. So it is integral. Let us simplify. Let us simplify. Minus 1 by t square and 1 by t whole square get cancelled. You take LCM. Take LCM. Again use substitution now. 1 minus 5t square equal to u. This can ordinary substitution, or you can go for trigonometric substitution. Root of a square minus x square. Okay. You can do ordinary substitution or trigonometric substitution. I can do even this problem by ordinary substitution. So I need not go for trigonometric substitution. So let us do substitution and hence see root u. We know root u is u power 1 by 2. Take u power 1 by 2 to numerator, which is u power minus 1 by 2. U power minus 1 by 2 du. Take 1 by 10 outside. We know integration of x to the power n dx. What is integration of x to the power n dx? X power n plus 1 by n plus 1. The same here. See, u power minus 1 by 2 plus 1 by minus 1 by 2 plus 1. Hence this 2 goes numerator. U power 1 by 2 is root u. Okay. Write u root u in terms of t. But we need answer in terms of x. So we know what is t in terms of x. Hence simplify if you want, which complete this type. Okay. So we have many types of problem. Listen here. If you feel easy, you go through this. Okay. Go through this. So here it is, see, evaluate. This is another type of problem. We may have square root of second degree polynomial or integral square root of second degree polynomial. It may be in the denominator or maybe the term, right? And hence see, write the rule here is write this as the term, the quadratic polynomial as a sum or difference of two perfect square terms. Okay. And then integrate using the formula. Integral dx by root of a square minus x square. Integral dx by root of x square minus a square. Integral dx by root of x square plus a square. Okay. So which you can see there are many problems. Let us discuss one or two problems. Okay. So here you see it is the first problem. First you assume I is equal to. So this is, we have the term in the denominator with square root and quadratic polynomial. Write this term as a sum or difference of two perfect square terms. It is a square term, 2ab term. Identify b square term, add and subtract b square term. Hence you will get the required thing, right? You will get the required thing. Here I have done, see. It is a square term, 2ab term. Hence you see 2ab term. Hence you will meet answer. When you see b square term, what is b square? Add and subtract b square. And these three will give you a minus b whole square. Simplifying this, you will get minus 1 by 4, which we can write 1 by 2 whole square. So which is like difference of two perfect squares. So let us write difference of two perfect squares. Then you go for substitution. You will meet answer. Okay. Once you know formula, you will meet answer. Okay. Which complete this type of problem. Okay. Let us see next type of problem. The integration may be with integrand px plus q by square root of ax square plus bx plus c, or integral px plus q into square root of ax square plus bx plus c. So you go through the types which you feel easy. Okay. If you think the types are difficult or difficult to keep in mind, listen here. You go through the types which you feel easy. Okay. So px plus q equal to, we have a rule here. Px plus q equal to a into d by dx of this second degree polynomial in the denominator plus b. Okay. A and b are constants which we can find the answer. Okay. After finding a and b, substitute it here. Okay. And then integrate. Let us see this in a problem. In a problem, see, you consider this integral 2x minus 1 by root of x square plus 5x plus 6, which comes under this type. Take this numerator term which is equal to a into d by dx of the denominator polynomial plus capital B. Differentiate this, right? We have to find the value of a and b. So let us equate the coefficient of x and constant. Let us equate coefficient of x, which is 2a, right? Only 2a. 2a is equal to 2. Then constants 5a plus b equal to minus 1. After finding a, substitute here a, you will get b. After finding a and b, substitute it here. Where will we substitute? In this equation. In this equation, substitute. So you have to write 2x minus 1 as 2x plus 5 minus 6. Okay. If you write 2x minus 1 like this, then you can get answer. Don't simplify 2x plus 5 minus 6. You will meet again 2x minus 1. If you write 2x minus 1 like this, you will meet answer. That's why we have done all these. We have done all these to identify how to write 2x minus 1 to get the answer. Okay. So 2x plus 5 minus 6. Let us separate. And this is, listen here, it's very easy. When you differentiate the denominator, you will get numerator. Okay, you will get numerator. When you differentiate denominator, you will get numerator. Here it is, you write it as sum or difference of two perfect square terms. By simply adding b square term, a square term, 2ab term, find b square term. Simply adding and subtracting b square term, you will get perfect square term. Difference of two perfect square term here. Okay. So after finding this, listen here, it is very easy. You have to substitute. Listen here, you have to substitute. It is root u, right? Other terms become du. Similarly, this term become. For both we have formula. Take this term to numerator. It is u power 1 minus 1 by 2. Where integral x power and dx can be used. Here it is, listen here, again use substitution for x plus 5 by 3. 5 by 2 as t. 5 by 2 as t. It become integral t square minus a square. Like integral x square minus a square. Dx by integral dx by x square minus a square formula. Okay. Use again substitution and integrate where you will meet the required answer. Okay. Very simple type. It is, see, you have to, if you use substitution, you know formula, which is log of x plus root of x square minus a square. And then finally get answer in terms of x. Please substitute u here. What is u in terms of x? Substitute it here. Okay. I have forgotten, you please substitute it. Which is this type. It is 8th type. If integral dx by a cos x plus b sin x. If we have integrand in the form 1 by a cos x plus b sin x, or 1 by a plus b sin x, or 1 by a plus b cos x, or 1 by a sin x plus b cos x plus c. So whatever it is, the integrand, we use this method. Put t is equal to tan x by 2. Okay, tan of x by 2. So the dt becomes, we know integration of tan theta is secant square theta. Then differentiating theta we have 1 by 2 dx. And the secant square theta can be written as 1 plus tan square theta, where tan square theta is assumed as t, so it is 1 plus t square. Okay, so I have found if I assume t as tan x by 2, then I will get dx as 2 dt by 1 plus t square. So this is the method we use when the integrand is in the form of all these. We know sin theta in terms of tan and cos theta in terms of tan, and hence sin theta is 2t by 1 plus t square, cos theta is 1 minus t square by 1 plus t square. So let us use these substitutions for dx, cos x, sin x in our problem. Okay, let us see a problem of this type. Integral 0 to pi d theta by 5 plus 3 cos theta, which is pi by 4. We have to prove the answer. So the expression is the form 1 by a plus b sin cos theta. 1 by a plus b cos theta. Okay. Let us assume this as I. Put t is equal to tan of theta by 2. Hence sin theta, cos theta the assumptions. D theta the assumption, right? Dx I have here, d in place of x I have theta. So I substitute all these in the given I, right, in the I, and simplify this. We have to simplify this. Okay. When you simplify this, listen here, take LCM, simplify, and you will meet the simplified answer. Okay, and this simplified answer can be further simplified, see, and which we can use integral dx by a square plus x square, which is 1 by a tan inverse of x by a. Get answer in terms of x, theta. Since the given problem is in theta, get answer in terms of theta. Okay. So after finding the, since we assumed I as simply integral without limits, look at I, which is simply integral without limits. So I have got answer of I. Now I substitute with the limits. I have got answer of I. Now I substitute limits both sides. So we know tan inverse of infinity. When you substitute pi by 2, tan of pi by 2 is infinity. Tan inverse of infinity is, what is tan inverse of infinity? Again pi by 2, right? Tan inverse of infinity is pi by 2. I have substituted here tan, first theta pi. When we integrate with respect to theta, we substitute limits for theta. Tan of 90 is infinity. Tan inverse of infinity is 90. Tan 0 is 0, or tan inverse of 0 is also 0, right? So which is the answer? Pi by 4. Hence we have proved the answer, right? We have proved the answer pi by 4. Let us see now the ninth type. Whenever you have integrand 1 by a square cos square x plus b square sin square x. Okay, we have to prove the answer. Let us consider the given integral without limits as I. I is the integral without limits. So let us simplify this, taking cos square x, multiply and divide by cos square x. I have multiplied by cos square x. When I divide each term by cos square x, I will get a square plus b square tan square x. 1 by cos square x is secant square x. Seeing secant square x and tan square x, definitely we know we can use substitution. Put t is equal to tan x. dt is secant square x dx. So let us substitute here dt by a square plus b square t square. Okay, t square, this is dt. So we know formula, right? We know formula. Let us do some more simplification. With the t square I have b square. Okay, I want t square to be free from coefficient. So I multiply and divide by b square. When I divide each term by b square, I will get a square by b square plus t square. Take 1 by b, listen here, 1 by b square is already outside. Integrate using formula. We know integral dx by a square plus x square, which is 1 by a tan inverse of x by a. In place of x I have t, in place of a I have a by b. Let us simplify and we find answer in terms of x. Now since we have assumed I, the given integral without limits, now I consider the given integral with limits. Since cos square x, sin theta is odd function, but sin square theta is even function. Since cos square x and sin square x all are even function, this integral 0 to pi can be written as 2 times of integral 0 to pi by 2. Since it is even. Okay. So I have found answer of this integral 1 by AB. So I replace it with limit 0 to pi by 2. Let us substitute the limits, upper limit and lower limit. We will meet the answer automatically. Okay. Next we have last type, 10th type. Whenever you have integral a cos x plus b sin x by L cos x plus m sin x dx. You look at this model, okay. Then you have to use numerator is equal to a into denominator plus b into differentiation of denominator. Whenever you have this model. So we have 10 types of problem. So the types which you feel easy, you go through the types, okay. Go through the types. If you can remember all the 10 types, it is good. Okay. You can see the problem which resembles this function, right? This integrand, okay. So let us take numerator is equal to a into denominator plus b into differentiation of denominator. Let us do a differentiate the denominator. Now I need to find the values of a and b. In order to find the values of a and b, let us equate the coefficients of sin x and cos x both sides. Equate the coefficients of sin x and cos x. You equate, see, equating the coefficients of, one second. Equating the coefficients of sin x and cos x, you will get two equations. Solve the equations, you will find the values of a and b. Okay. Substitute the values of a and b in the given the assumed first equation. So this numerator should be written as sum of these two. That is what our assumption says, okay. So let us replace numerator by this one. Separate the integral automatically using substitution method and direct integration, you will find answer, which complete all the 10 types of problem, okay.